All right, guys, going to do an example finding an inverse of a 2 by 2 matrix, kind of a long way with Gaussian elimination. And I'm just going to kind of go through really quick why this works, but there is a link in your document for a more in-depth example following the link for this video. And the reason this works, if we're trying to find an inverse, then we know that our inverse is going to be some matrix where we multiply it. So I'm just going to call it like A, B, C, D. If we multiply two matrices that are inverses, then we would get the identity matrix. So 1, 0, 0, 1. So, excuse me. If we actually multiply these right now, and that's why this section also has matrix multiplication in it, I would have my first row, right, times my first column to start off. So it would look like 5a minus 10c, right? I have A, really adding, negative 10c for the first row, first column. For the first row, second column, right, I'm using the first row from this matrix and the second column from this matrix. So we would get 5b minus 10d starting off. And then we could go through and do the same things, I lost a letter there, to get the second row here. So I would have 4a minus 6c using this first row, and then first row, second column for this position, 4b minus 6d. All right, so kind of long story short, if we look at both of these little, I don't know, I guess columns, we can call them over here, we have two little systems of equations, 5a minus 10c, 4a minus 6c. Same coefficients over here, 5b minus 10d, 4b minus 6c. So we've got like two little systems with the same coefficients equal to this guy. So since that's true, we can actually set up one kind of big doubly augmented matrix. So if you want more about why this works, you should go watch the second video linked above. But otherwise, what we're going to do is set up this double augmented matrix where here's my coefficient. So I've got 5, negative 10, 4, and negative 6. On the other side, it's my answer, 1, 0, 0, 1. And we're solving for this matrix here, A, B, C, D. So I'm going to use Gaussian elimination with this big doubly augmented matrix. And first I'm going to try to get the 1 here. So I'm going to do row 1 minus row 2. So we'll get a 1, negative 10 minus negative 6. Should be a negative 4, I believe. Row 1 minus row 2 is 1. 0 minus 1, negative 1. So hopefully I'm not making any silly mistakes here. All right, so I've got my 1 in the first row, first column. Now I want to get rid of this 4, so I'm going to do negative 4 row 1 plus row 2. So negative 4 row 1 would be 16 plus negative 6, 10. I'm actually going to grab my calculator and throw it in there just to make sure I'm not making any silly mistakes here. So negative 4 row 1 plus row 2. I think I'm looking good. Negative 4 row 1 plus 0 is negative 4. Negative 4 row 1 is 4 plus 1 is 5. So hopefully I'm going okay so far. This looks like going to be a little messy for our inverse, which a lot of times they are, so we're going through. Okay, 2 more steps. We want to get this guy to be a 0 and this guy to be a 1. So I'm going to make the 10 a 1 first. That's going to be my goal. I'm going to go over here, and I'm going to do row 2 divided by 10. I will get fractions. It'll be a little messy, but that's okay. I'll 4 tenths, which is -2/5. and 5/10, which is 1/2. All right, so my last step is going to be to get a 0 in this position. So I'm going to do 4 row 2 plus row 1. So we've got our reduced row echelon form on this side. And now I'm going to use my calculator to help me out. So I'm going to do 4 times -2/5 plus row 1, so plus 1. And that gives me a -3/5 here. And then 4 times row 2, so 4 times 1/2 is 2, plus row 1. So that should be a 1, and I think I'm all set. So what we have on the right side here is our answer. Instead of it just being one column like XY we usually have, it matches up to this size, which means our inverse will be that matrix. So this is definitely the long route for finding an inverse matrix. We're going to go over the short route, the kind of shortcut in a second, but this will work for any size square matrix to find the inverse. The way that we're going to go kind of with the determinant down below only works for 2x2s. So if you ever need to find like a 3x3 or 4x4 inverse, this would be the way to go. Now we only will do 2x2s by hand. If you're trying to find the inverse of a 3x3, you'll be using your calculator for that. And to do that, you would literally just type this in your calculator, like we did back when we were solving with the calculator for Gaussian. So you type that in. I would put it in as like matrix A. And then you go and select your matrix. So in the calculator, once you select a matrix, it should look like this. And you can use the inverse button, right, which is actually the button that we use for matrices. So then you hit X to the -1st button, and you hit enter, and it should give you the inverse matrix. So I think I put it in here. Just checking that I put it okay. Try it out with your calculator. This is what you should get. 13, 6, -4, -12, -5, 3, 5, 2, -1. If you're not sure, maybe give it a Google, but you do just input the matrix and then select your matrix on the main screen, X to the -1st, find the inverse, hit enter, and it should output this inverse matrix.